Hi guys, today is a video about some viewpoints of the Leetcode algorithm learning. Let's start. Is algorithm useful? Which group should learn algorithms? At first, I offer you a formula. Data structure plus algorithm equal program. This means as long as your education or career is related to programming, you need to know about it. There are two categories of people. The first category is software engineer who has to cope with the interview and routine work in tech companies such as Funk and TMD. The second category is the practitioners who need to scrape or analyze data in economics, finance, big data, artificial intelligence, hardware, embedded, and other industries. Let's talk about some of the misconceptions and biases I've heard that can hinder your progress. Only beginners are need to practice the algorithm. Is it right? Some people have a lot of work and study experience, or at a high position like CTO, PhD, senior software engineer, artificial intelligence big data scientist. You would say, how high-end I am? How would I go to practice Leetcode this kind of elementary knowledge? This is business for college students. Only system design technical knowledge, engineering ability are important for me. Yep, it's not that these are not more important than algorithm. They are also extremely keys. But what I mean is that DSA is that basic skill. It would be weird if you didn't master it. If junior member get that you as a senior person don't know this, it will be awkward for your face to hang on. Actually, Leetcode is useful for any level of techie stuff. Then let's discuss the importance of algorithms. First, algorithms are the foundation of the computer science. The reason why I say so is that data structures are used to describe the construction of all the information in the real world. For example, a queue for the movie theater is a queue. The organizational structure of your company or a web page is a tree. A map of subway lines is a graph. And a phone book is a hash table. An algorithm describes what you build on this data structure to do, such as adding an employee to a company's architecture tree, or searching the nearest route on subway graph. Programming is really an abstraction of our world, so you have to know DSA to program. If you don't, you are like a student who can't tie knots, a lawyer who doesn't know the clause of the law, or a basketball player who can't dribble and shoot. Second, algorithms are an efficient way to test your capability. It facilitates the screen of talent. The United States interview will always test DSA. Don't test the application framework. They believe that the application framework can be quickly learned by the search engine. Interviews examine your algorithm generally require you to complete a complex whole function with no bugs. This is very challenging. It can help the interviewer to judge your ability in a short period of time. Your code should be written fluently, clearly named, organized, readable, and bug-free. It is the proof of your absolute code ability, stamina, and effort. Third, the algorithm improves your coding speed and quality. People often say that interviews is like building rockets and the job is tightening screws. Algorithms are indeed very hard to hitting basic skill. If a person's Leetcode level are not good, his programming ability is definitely problematic. Some of the concepts included here are array, string, linked list, partitioning, stack, queue, heap, double pointers, sliding window, backtrack, dynamic programming, binary search tree, and union find. You definitely use them in your work. You may not be able to use them because the difficulty of the product is low, but more because you don't know some of these things you need to know. In fact, after you practice, you can quickly express your intention by the code, even more fluently, faster than in Chinese. After training, your understanding of code principle and your speed of writing code increase exponentially, and you learn how to design the code. The code will have few bugs. After intensive training, you will be quite confident, sure that you are the advanced coder. Before exercise, you write a feature in several hours, while after it, you could complete it in 1.5 hour, and meanwhile, the quality will be much higher. Now, next topic is our learning goals. First, the amount of problems. There are about 30 knowledge points in total. For each knowledge point, practice 5 to 10 medium difficulty problems, depending on how well you grasp the patterns of each type of problem. Practicing a total of 100 to 300 problems should be sufficient. Second, bug-free. How to write code that is bug-free. The meaning of the bug-free is to cover all the input test cases and write it all at once without bugs. If you define yourself as a master, there should not be many obvious defects. Why would you want to have a boss who recruits programmers and spends twice as much time fixing bugs? Third, speed. For medium quizzes, aim to solve each one in an average of 20 minutes. If the interviewers see that you have this speed during the interview, it will leave a very good impression. Fourth, for the Leetcode weekly contest score, it is sufficient to be able to make the first 3 questions and know the test point of question 4. Learning procedure. First, look at the textbook. If you are changing your major or study finance and economics, I recommend the Webpack book written by Keishan in 2023. In my opinion, watching Coursera, Udemy, or reading our Chinese textbook is more efficient. Please ignore my recommendation if you have studied it in college. The step is so important. It is the first of 2 steps that I personally feel are the most blocky in terms of progress. Second, focus on practicing by type, and there is a sequence for types as well. On Leetcode, the problems are sorted by their frequency of use in interviews and jobs. We can solve problems by type and by frequency of appearance. Easy problems can be used to get a feel for the process and warm up. The main focus should be on medium problems. There's no need to do hard quizzes, but practicing classical hard quizzes occasionally can be beneficial. Many people have categorized the problem, such as Keishan and Leetcode. The official site also has a post with 20 major categories, and each major category is further divided into subcategories. However, the number of the problem is still too large, so we can just do a few problems for each subcategories. So there is also a sequence of subcategory. Look at this flowchart. The third step, doing the top 100, top 115, and participating in weekly competition I used to test the effectiveness of your studies. About total time, I've seen some non-major students do it in 2 months. Some of them turned off their cell phones and keep away from WeChat moment. 2 months, very admirable. I personally think a time span of 3 months to 1 year is reasonable. 7 tips. Tip 1. Look at the answer earlier. If you're stuck after 10 minutes, immediately refer to the solution and discussion in the forum. If you are still stumped, search for answers on GPT, Google, and YouTube. The quality of results you find using English keyword is generally much higher than with Chinese keyword. However, Some problems are indeed very difficult. I once spent half an hour understanding a problem and 5 hours solving it. This is normal, and many famous coders started out the same way. My old law school buddy told me that the key was patience. He said to dissect the text, read it word by word, and go over it multiple times to really get it. I gotta admit, it's a bit of grind, but it actually works. Tip 2. Don't be anxious. Prioritize quality over quantity. Focus on understanding the underlying concepts and logic rather than memorizing templates or formula you own purchase after grasping the underlying principles. Thoroughly comprehend past questions before attempting new ones. I used to rush into new problems, prioritizing quantity over quality, which ultimately wasted more time and yielded poor results. Tip 3. Take short notes, review them. Read them before you go to bed, tap them again the next day, and tap them again on the weekend. Hit it again a month later. Reviewing actually takes very little time. Just flip through it in a few moments. After 6 months, and then again, the skills will be engraved into your brain. Tip 4. Think through the steps clearly before you start writing. Spend 70% of the time thinking and 30% of the time coding. Write out the steps first, then write the code. This way, you will be faster and more accurate. Tip 5. Don't learn by watching individual videos in isolation. These days, too many people like to use fragmented approach to learning things, picking up a little here and a little there. I believe that you have seen a lot of this phenomenon on Xiaohongshu and Zhihu. This will only lead to anxiety, be not the correct way to learn. You should first draw a general outline for yourself. Tip 6. Make a good summary. And if you don't have the time, you can refer to the summary articles by famous coder, such as K Shen, Tian Yi, San Ye Jie, Carl, Tu Mei. This is the second step that I personally feel has made the most progress. Tip 7. Avoid doing weird, off-topic, or brain-teaser questions, as well as most non-classic hard questions. Let's wrap up with 3 frequently asked questions. First, some people argue that with the existence of GPT, there's no need for me to learn anymore. However, I personally believe that without systematic training, it's impossible to develop critical thinking skills. Simply relying on GPT for answers will hinder one's progress compared to systematic learning. Second, some people claim that I'm incapable of learning, have poor memory retention, and make numerous boundary errors. I believe there are 2 primary reasons for this. Firstly, you never truly grasped the concepts in the first place. I've experienced this before, where the solution explanation was subpar, and I ended up following along in a hazy manner, writing code haphazardly and somehow managing to pass the test in a muddled way. The other factor is clearly lack of revision. Third, sometimes, especially in the beginning, it can feel extremely painful. Good methods help avoid detours and save time. It's essential to build a strong foundation and outline a clear plan. A significant amount of thinking and practice is necessary. For ordinary people, this process is bound to be painful and tedious. It seems like the most exhausting path, but it's actually the shortest one. To summarize, practicing algorithm can be challenging for everyone. Don't doubt yourself. Just keep practicing the right way, and you will eventually succeed. My leaders, teachers, classmates, and colleagues, if there are any mistakes in this video, please feel free to point them out. I know it's hard for everyone, and I also face some challenges in my work and life. So I hope to gather everyone's wisdom and share more to help more friends. Thank you for watching.